Question number 28. By mistake, a voltmeter is connected in series and an ammeter is connected in parallel with the resistance in an electrical circuit. What will happen to the instrument? A. Voltmeter is damaged. B. Ammeter is damaged. Both are damaged. None is damaged. So normally voltmeter is connected in parallel, but here it is connected in series. So connections are like this. This is voltmeter. This is a resistance, and this is ammeter. So this is RV. This is RA. Since voltmeter has high resistance RV and RV is in series with resistance R. Therefore, current through the circuit get reduced considerably. That is, I decreases. Therefore, current through ammeter is also small within limit. Therefore, ammeter as well as voltmeter are not damaged. Therefore, the correct choice is D. D is correct. याचा इंटरनल रेशन हाय त्याच्या हा करंट कमी झाला म्हणजे त्यातला काही पार्ट इकडून जाईल तो करंट कमी होईल. सो करंट इज विदिन सेफ लिमिट, नो डॅमेज ऑफ एमिटर. दिस करंट डिक्रीजेस, therefore no damage for voltmeter. So both the meters are protected from permanent damages like this. Next, question number 29. B1, B2, B3 are the three identical bulbs connected to a battery of steady EMF with the key K closed. What happened to the brightness of the bulb B1 and B2 when the key is open? So circuit arrangement is like this. So this is bulb B1, this is B2, this is B3, and this is the key. This is the battery of E. B1, B2, B3, E, like this. So, say this resistance is R1, this resistance is R2, this resistance is R3. Since 3 bulbs are identical, therefore R1 resistance of the first bulb is equal to R2, resistance of the second bulb is equal to R3, resistance of the third bulb is equal to R, like this. So this current supplied is I1. Now it will divide into the two parts. This is I2, this is I3, and this current I1 will return. So this point will denote by C, this point is denoted by D, like this. Case first, when the key K is closed, then total resistance in the circuit RT is equal to R1 plus R2 parallel R3 is equal to R plus R parallel R is equal to R plus R by 2, that is equal to 3R by 2. 3R by 2. When key is opened, then new resistance R dash P is equal to R1 plus R2 because no current through R3. So this is equal to 2R. So this is equation 1, this is equation 2. 1 and 2 shows that R dash T is greater than RT. Resistance वाढला. Therefore, current decreases. Current I1 decreases. Therefore, brightness of the bulb B1 decreases. Decreases. High grade local blood. Now, second case. Now, what is about B2? When key is closed, current through R2, current through B2 is I2 is equal to I1 minus I3. I1 minus I3. But when the key is open, then I3 becomes 0. Therefore, new current I2 dash is equal to I1. Therefore, current through bulb B2 increases. Therefore, bulb B2 will light brighter. So the brightness of the bulb B1 decreases, the brightness of the bulb B2 increases. B1 decreases, B2 increases, and therefore correct choice is C. C is correct. So, what is the effect of open and closed position of the key that we have to study? First, we have to consider what is the change in the brightness of the bulb B1. So, when key is closed like this, so C and D point are shorted together. Therefore, these two resistances are in parallel. So, total resistance is equal to R1 plus parallel combination of R2 and R3. So, all these resistances are RRR. Therefore, R plus R parallel R, that is R by 2. So, total resistance is equal to 3R by 2. Now, when the key is open, there is no flow of current. So, only R1 and R2 are in series. And R1 and R2 are in series, therefore, total resistance becomes 2R. So, this is 3 by 2R, this is 2R. So, new resistance after opening the key increases than original resistance. Resistance increases, therefore this current decreases. Current decreases, therefore B1 will light with the decrease in the intensity. So its brightness will decrease. Now, when the key is open, the current I1 coming from this B1, it is divided into the two parts. So some current is flowing through this bulb B2 and therefore less current will flow through the B2. B3 मधून काही करंट जातो. So some current flows through B3 as long as the switch is closed. But when the switch becomes open, then all the current will flow. The current coming from B1 will flow through B2 directly. Therefore, current increases. Therefore, B2 will bright become more bright. So brightness of B2 increases, brightness of B1 decreases, like this. Next, question number 30. In a neon gas discharge tube, any plus ion moving through a cross section of the tube each second to the right is 2.9 into 10 raised to 18, while 1.2 into 10 raised to 18 electrons move towards left with the same time. The electronic charge being 1.6 into 10 raised to minus 19 coulomb, the net current is. So problem is very simple, basic electricity, static electricity. So any plus ion are moving in the direction. So this charge is Q1. It is a positive charge, therefore I1 is in the direction. Now the electrons are moving towards left, minus E. So this is Q2. तो यहाँ Q2 चा चार्ज निगेटिव्ह आहे, इलेक्ट्रॉनच्या सोच्या ऑपोजिट डायरेक्शनने करंट होतो, म्हणजे I2 पण या डायरेक्शन. सो टोटल करंट I इज इक्वल टू क्वेश्चन मार्क Q1 is equal to charge of N1 neon ions. Therefore, Q1 is equal to N1 multiplied by E. This is equation 1. Q2 is equal to Q1 is positive charge moving towards right, moving towards right. Therefore corresponding current I1 is also towards right, and I1 is equal to Q1 upon T. Is equal to N1 into E upon T. This is equation 2. Now Q2 is equal to charge of N2 electrons, E minus. Therefore Q2 is equal to N2 multiplied by E. This is equation 3. Q2 is a negative charge moving towards left, therefore corresponding current I2 is also towards right. and I2 is equal to Q2 by T is equal to into E by T. This is equation 4. So both the currents are in the same direction. Since currents I1 and I2 both are in the same direction towards right, are in same direction towards right. Therefore, total current IT is equal to I1 plus I2. Using 2 and 4, total current IT is equal to N1 into E by T plus into E by T, but T is equal to 1 second. Therefore, total current IT is equal to N1 plus N2 into E. This is equation 5. So substitute here. So IT is equal to total current IT is equal to N1 की value आपल्याला दिलेली N1 number of neon 2.9 into 10 to 18 plus into म्हणजे number of electron तो पण दिलेला आहे 1.2 into 10 to 18 and outside the bracket 1.6 into 10 to minus 19. So this sum is 3.1 into 10 to 18 multiplied by 1.6 into 10 to minus 19. So 3.1 into this, so 6, 4.96 into 10 to minus 1 ampere. This is 4.1. So this is equal to 1665. So 656 into 10 to minus 1. That is equal to 0.656 ampere. That is equal to nearly 0.66 ampere. That is right. So total current is equal to 0.66 ampere towards right. Direction पण आपल्याला विचारलेलं आहे. So the correct answer is B. The correct answer is B. इथे राउंड ऑफ केलेलं आहे त्यांनी. B is correct. तर राईटला 2 करंट दिलेले आहे त्याच्यामुळे आपल्याला कॅल्क्युलेशन करावेच लागते. So we know the basic rule for the current. Current flows in the direction of positive charge. Current flows in the direction opposite to the negative charge. So electron has negative charge, therefore electrons are flowing towards left, therefore corresponding current I2 is towards right. These are positively charged ions, neon ions. They are moving in the right direction, so corresponding current I1 is also in the right direction. So I1 and I2 both are in the same direction, therefore total current is IT is equal to I1 plus I2, and I is given by Q upon T. So Q1 is equal to this total charge of the neon Q2 is equal to total charge of the electron moving, and therefore simplification gives this much ampere current. T is 1 second. The number of electrons are moving in 1 second. Therefore, T is substituted as 1 second, like this. Next, 31. A capacitor of 10 microfarad has a potential difference of 40 volt across it. If it is discharged in 0.2 seconds, the average current during the discharge is so discharging current and charging current or any current has the same formula. So discharging current I is equal to Q by T, but capacity C is equal to Q by V. Then charge Q is equal to C into V. 14 months. Therefore, I is equal to capacity C, potential difference V upon time taken T. This is the formula. So this is the average discharging current flowing to the circuit. So only we have to substitute. C is equal to 10 microfarad. That is equal to 10 into 10 raised to minus 6 farad. V, applied potential difference, is equal to 40 volt. And the time taken to discharge is 0.2 seconds. So substitute here. So I is equal to 10 into 10 raised to minus 6 multiplied by 40, 1012. So this is 0.2 means it will become 5 multiplied by 400 into 10 raised to minus 6 ampere. 2000 into 10 raised to minus 6 ampere. So 2 into 10 raised to 3 into 10 raised to minus 6 ampere. So 2 into 10 raised to minus 3 ampere, that is equal to 2 milliampere. So correct answer is A. A is correct. Now I will add one more point. If the charge Q decreases non-linearly with respect to time t as shown in graph. Q by T. Then current I is equal to current I is equal to A, B, C, D, P, B, L, M. So I is equal to area P, B, L, M, B. So current is calculated by considering this area method, geometrical method, and this area can be calculated by either integration method or by geometrical method like this. म्हणजे करंट कॅल्क्युलेट करण्याची ही पण एक मेथड असते. नेक्स्ट क्वेश्चन नंबर 30. In the circuit shown as shown in the figure, the potential difference between X and Y would be equal to 0, 20 volt, 60 volt, 120 volt. तर बॅटरीची EMF 120 व्होल्ट दिलेली आहे आणि आपल्याला तेच आन्सर डायरेक्ट देता यायला पाहिजे कारण सर्किट ओपन आहे. ओपन सर्किटच्या कंडिशन आपण लास्ट इयरला बघितलेलं आहे. सो सर्किट इज गिवन लाईक दिस. This is the circuit arrangement. So this E is equal to 120 volt. R1 is equal to 40 ohm. R2 is equal to 20 ohm. And these 2 points are given by X and Y. VXY is equal to question mark. So there is a current I. If this X and Y are closed up, then this is like this I. So EMF E is equal to capital V plus small v. So this is equal to EMF E is equal to Vxy plus I into R1 plus I into R2. This is equation 1. Since between X and Y the circuit is open, therefore current I is equal to 0. Current I is equal to 0. Therefore equation 1 gives E is equal to Vxy plus 0 plus 0. Therefore 120 volt is equal to potential difference between the point X and Y. So potential difference actually open circuit मध्ये EMF and TPD दोघे सारखे असतात. Potential difference between X and Y is equal to Vxy is equal to EMF E is equal to 120. So this is the correct answer. Open circuit and closed circuit च्या फॉर्म्युला पण लास्ट इयरला बघितलं आहे. So correct choice is D. Therefore D is correct. Okay, we will stop here. Remaining problem we will see in two sessions.